Hello everyone, welcome to day 21 of competitive programming. Yesterday we have participated in a coach of contest, so we'll be actually solving those questions, which I will also explain the questions which I have solved. Actually, it was a little weak performance in the challenge actually, because if I go to my profile, I have dropped to 1 star from 2 star. Actually, I lost 34 ratings. I've dropped from 1412 to 1378. It's not a bad drop. uh, okay, so in next contest I can make it through to 2 star. It is starters 80. In this, the division I have participated is division 3. Well, this was my rating performance. For some reason I couldn't solve these two questions, which was been solved by maximum people. So let's just see single use attack. These are pretty basic questions, which which will test how good you are in syntax or how do you know about basic concepts, I guess. Our difficult rating is 777. So let's read the question actually. Single use attack. Let's open our terminal. Today I will be explaining all these questions, and I have that's it. And we'll be solving these two questions also. We'll be trying to solve these two of them. Actually, I guess I have pretty much tried to solve them. I have written few codes. If I go to I need to go to contest to check what I have written for this code. So we'll be solving. Anyways, let's read this single use attack question. Well, Chef is playing a video game and is now fighting the final boss. The boss has H health points. Each attack of Chef reduces the health of the boss by X. Chef also has a special attack that can be used at most once and will decrease the health of the boss by Y. Chef wins when the health of the boss is less than or equal to 0. What is the minimum number of attacks needed by? So we need to print the minimum number of attacks that are needed for the chef to win. So first line of input contains T test. Okay, let's go to cd/cp and we'll create a file single use.cpp, and in this file we'll copy this code so that it will be easy to see, and I can also zoom if it's necessary. Okay, now we are just taking the test case. We are reading the test case. In each test case there are 3 values. For me, I have taken n, s and a. You can take h and xy. It is better to take h and xy so that you will not confuse between which is the, here h is the health points and x is the attack by chef and y is the special attack, so it will not be a confusion. So first you will remove that. So to find the minimum attacks you need to use the special attack at least once. So we are using our special attack here at least once. After subtracting, I'm taking a variable count. I'm initializing count to 1 because since we have used special attack, it is counted as 1 attack, right? So that's why I have counted. I have increased the or initialized the count to 1. That is the reason for it. And next, while loop. I have taken the while loop while n is greater than 0, n minus equal to s. You will be subtracting and counting the number of attacks. Since our constants are very small, we can use the for loop here. And I have submitted it. It got submitted. So I have solved this question. So it's a pretty basic question. Next, we'll be seeing the next question. I'll close this file, and this file will be available in GitHub, or should I make it available? Because I have not solve it on the camera. Okay, we'll worry about it later. Anyways, running comparison. So in this question, uh, like Alice and Bob recently got into running and decided to compare how much they ran on different days. So they each ran for n days. On the 8th day, Alice ran AI meters and Bob ran BI meters. So instead of reading all this, I'll just explain you what is happening here. So here, Alice ran on first day 100 meters and Bob ran 300 meters. So Alice will be happy if he ran twice the distance, twice more than the distance Bob ran. Like in this case, Bob ran only 100 meters. Alice will be happy because he ran 300 meters. Twice of 100 is 200, but he ran 300 meters. So Alice will be happy. In the first case, Bob will be happy because he ran twice the distance Alice ran. More than the twice of the distance Alice ran. So, but the question is, you need to print the number of days both are happy. Both will be happy if none of them ran twice of each other's distance. That is the question. So let me copy all this code, and its rating is 899. Run compare.cpp. So here we are reading two loops. Okay, first we are reading the test cases, then we are for each test case we are reading two loops for A and B. Next we'll go for the count, since we need to print how many times or how many number of times both are happy. Next we'll take the absolute difference between both of them and we'll find the minimum of both of them, and we'll check if k is greater than m. If their absolute difference is greater than the minimum of any one of those, then it is like they have run twice, you can say, right? Since here it is absolute difference is 200 and 200 is greater than 100, so they have run twice. So in that case you will not be doing anything. In other case you will be just increasing the count and you will be print the count. That is how I have solved this question, running comparison. Next question, which is equal elements. In equal elements, this is a 1100 rated question. So basically here you will be given an array A of size n. In one operation you can do the following. Select indices I and j and set ai is equals to aj. Find the minimum number of operations required to make all elements of array equal. This is, you can say, one of the conceptual questions, you can say, or questions that will repeat. This kind of concepts will repeat. Like if 1 2 3 is the array given, you can select 1 and 2 and change both of them to 3. Okay, or sorry, you can select 1 and 2. If you select 1 and 2, then you will equal them. That means either you change first one to 1 or second one to 1. Okay, that's how you do it. But you need to find the minimum, right? So if you select the here and if you change the second one to 1, this is the case. Next case you will select these both and you will not change it to 3, you will change it to 1. So now our array is equal. So to solve this case, you will find the maximum repeating element. If for example it is better to solve these two numbers and these two numbers to 3, because since 3 is already majority, out of 8 numbers 4 of them are same. So now the number of operations has fallen to 4. So choosing to change to 3 is better option. If you want to change to 4, you need to change 6 numbers to 4. If you need to change all numbers to 1, which is really bad, then you need to change all the 7 numbers to 1. So to reduce the number of change, we'll take the highest repeating element. So here the code to find the highest repeating element. I have used the map, unordered map, which uses hash tables instead of balanced binary trees, which only map uses. So I have calculated all the numbers frequency. Then I have taken a maximum frequency variable and I have iterated over the map and found the maximum frequency value, which is I dot second, and I have just printed the n minus maximum frequency, which is, so total number of elements are 3 and the maximum frequency is 1, so 2 is the answer. Here total number of elements are 4 and the maximum frequency is 2 elements having same value, so 4 minus 2 is the answer. That is a question, that is a solution here. That's it. So let's try to solve prefix permutation. How long we are having? Oh, I actually forgot to on the timer. So it's been 11 minutes I have started. So let's take a timer of 50 meters. Okay, here it is displaying me time. Now yeah, we'll be solving prefix perm. Actually it is 1200 written, so I should have solved it in the contest itself, so it is a little disappointing. Actually we need to have this file inside SCP. Yeah, now we are having that file inside CP directory. Okay, so he will be giving us let's read the question. Prefix permutation. You are given an array n. Your task is to generate a permutation P of size n such that for all I less than or equal to n, P of j is not divisible by j. So P of j is not divisible by I. In other words, the sum of prefix of length I greater than 1 should not be divisible by I. Okay, if array size is 1, 2, 3, so 1 plus 2 should not be divisible by 2, and 1 plus 3 should not be divisible by 1 plus 2 plus 3 should not be divisible by 3. In this case it actually fails, so the array shouldn't be in this order. Note that a permutation of size n contains all elements from 1 to n exactly once. Let's take our array and we'll remove the array part from here. Only we are reading n for each test case. Now in each case multiple such permutations exist, sorry, and if no such permutation exists, print -1. So what I thought while the contest is, for every odd number the answer will be -1. I have just seen here there is a pattern I have observed, like 3, 4 is being printed, then 1 and 2 is being printed. Here 1, 2 is printed, then 4, 6 is printed, 3 and 5 is printed. That means one number is smaller number, the next number is larger number, next again a larger number, actually another larger number. I thought to rewrite this second test case, the second output, to a different pattern. What was it actually? I couldn't remember. I guess it is this. I'll print 2, next I'll print 1, after that I'll print 4, next 3, Then I'll print 6, next 5. Okay, this is the way I wanted to read it, same as this here 3 4 1 2. Even here for 3 4 1 2 also I'll print to this part 2 1 3 4 3, because multiple permutations exist, right? So if you take this case, 2 plus 1, it is 3, not divisible by 2. 3 plus 4, which is 7, not divisible by 3. 7 plus 3, 10. 10 is not divisible by 4. So this was the pattern I thought. Then I felt it is little complicated to execute it, and then I changed my to permutation subsequence question and tried to solve it. So now since we are having time, let us try to implement that. Okay, after this we can just read. Okay, it's an if else, right? No need of return statement. Okay, in else part I'll be writing a for loop and we'll start I from 1 instead of 0, and next I'll be printing I plus 1. After printing I plus 1, I'll take a little gap and I'll print I. Okay, and it's not endl. Let's provide some gap. After the for loop we'll go for the endl, and that's it. We are printing the array. We're printing -1 and endl. So here initial I value is 1, so I plus 1 is 2. Then we'll print the I, so which is 1. Then we'll print space. Next, if I is less than n, its value will be incremented to 2. Then we'll print 2 plus 1 3, and we'll again print 2. So instead of incrementing it once, if we increment it to twice, we here will be having 4 and here 3. Yeah, perfect. So let's just compile. Yeah, we got the values, but we cannot compare with the sample test cases. So let's just submit it. Yeah, we have completely actually done 50. Yeah, it's got submitted actually. I am little disappointed in solving this question. Because I couldn't solve it in the contest, but I have implemented the same idea right now, and we got the solution here. Okay, anyways, let us solve this question and we will end it for today. So I have actually tried here few ways. So the question, should I explain the question or should I read the question one more time? I'll read you the question again. Let's create before. Okay, it's 1500 level, but I'm having a little kind of intuition to solve this question. I'll explain it to you. So basically they are given as a array A consisting of n positive integers. A permutation subsequence of length m is a subsequence that repeats a permutation of length m. Okay. Now Jeffina asks Jeff to find the count of permutation subsequence in array A. The count can be very large, so output it modulo 10 power 9 plus 7 as a reminder. So we'll just divide the number with this number and we'll divide the remainder. So a subsequence of an array is obtained by deleting some elements from the array without changing the order of the remaining elements. A permutation of length m is an array of length m in which every element from 1 to m occurs exactly once. Okay, first line will give t, next line n, the length of array. The next line contains n space separate entities, the elements of the array. So they will be given as an array. From that array, we need to select how many arrays we can form in this way. 1, 1, 2. This is actually 2, 1, I guess. 1, 2, 3, 1, 3, 2, 1, 2, 3, 4, 1, 3, 2, 4. Because the next elements they change the order. So my intuition was, we'll find the numbers that are consecutive from 1. And after finding them, we'll print the number of operations. So to find them, I have used, okay, let's just copy here and paste all these things. So so I have found the elements. After finding them, actually we have solved this kind of question in one of our videos. I couldn't remember the questions. What is a code? So after finding the numbers, we got count, and after getting the count, the number of elements, the array size, the array can be, total number of subsequences will be each element frequency multiplied by previous number of subsequence frequency. So that is like, if we take 1, then its total number of subsequences will be this element's frequency multiplied by previous number of number subsequent. Like if we take for example 2, I guess, with the 2 we are having one subsequence, and before we are having two subsequences with 1, the one and now and the one before, so it's 2 into 1. So next, if we'll go for 3 into 2 has also 2, will not consider this thing for now, and 1 is also having 1, so 3 into 2, it is 6 actually. So for 3 we got 1, 2, 3, 4, 5. We actually got 5 here. 5, 6. If for 4, it will change. So you'll find the numbers from 1 to 4, and you will be changing its subsequence. So basically, actually we guess we need not solve here. Sort here. We'll maintain a variable x equal to 1. Okay, I also read the array. It is basic, right? Test cases we are reading, we are declaring n, we are reading it, then we also read the array, then we have defined our modulo. Now we took a variable x is equals to 1 and count equal to 0. Okay, after that we took a for loop. I guess we need to use map for this to find the frequency of elements. So if the first element is present, then we'll increase the map. That's it, right? Actually we'll need to have count as 1, and x will use for previous subsequences, I guess. So we'll go for 0 there. And now let's take a map int comma int, and we'll go with the frequency. Then we'll read from 1 to n. We'll iterate over this array a, which we have just read, and we'll say m of a of I plus plus. You can do that here itself, I guess. So let's cut this. Let's go for map int comma int frequency, and next we'll be reading our frequency of a of I plus plus. Okay, we got our frequency. Next we'll just remove our this. Yeah, we need to print the module of the number, but first let's take our I value. Will start from first element and will increase the I, because it is the first element into previous element, right? Previous element's frequency. So our count will be multiplied with m of frequency of I. Okay, if 1 is there, we'll multiply with 1. If 2 is present, we'll multiply with 2. After multiplying, we'll just divide it. We'll take the remainder using our modulo, because since this value will increase, right? So even though we have declared it in LL, its value will be increasing. It will be so big. So we're going to divide it with modulo. Next, we will add our count to number of permutations that we got, which is our x value, number of permutations. We'll add here the count, and next we'll also take the remainder of by using modulo. At the end, we'll print our number of permutations. Is it that's it? I'm feeling that's it. There is nothing more to this question. So sorry. Didn't mean to press Ctrl S there. Now let's submit. If this question gets submitted right now, we'll be ending our recording. Currently running test case 3. It did got submitted. I thought it wouldn't get submitted. Well, it did got submitted. Okay, how long we have been recording? So it's been nearly half an hour. I guess that's it for today. We'll be applying 5 questions, in which 3 of them are not necessary. I guess you should do like this, which are very low level questions, right? I mean, it's not low level, it's comparatively less rated questions. We need to git commit as day 21, right? And also, okay, if I need to git push, I need to give my SSH key. So which I'll not be doing here. Okay, why did it get stuck? So we'll remove the layout file. Next we'll add all the elements to the stacking area. Next we'll commit it as day 21. That's it. Yeah, we are done. Okay, we'll stop the timer also. it doesn't work. Yeah, that's it for today. Thank you.